This video is on atomic structure. So in our last video, we looked at the human endeavor into figuring out what an atom was made out of and about the existence of atoms to begin with. Bohr made great progress in Rutherford in figuring out that we had protons and neutrons there in the nucleus and electrons outside of the nucleus. But we had to modify Bohr's model quite a bit because his electrons were a little more weird than we initially suspected. So right now, our current atomic model is the electron cloud model, or the quantum model, we'll also refer to it. We'll talk more about the quantum model as we go more into electrons in our next unit. Okay, so with the electron cloud model, we've got protons and neutrons located inside the nucleus, and they're actually like jam-packed in there. The nucleus is really, really tiny compared to the rest of the size of the atom. And then the electrons are zooming around outside of the nucleus somewhere, and we generally consider them within energy levels or certain distances from the nucleus. If you were to take an atom and blow it up to the size of a football stadium, stands and all, the nucleus would be the size of a dime. So it is really, really tiny, especially compared to the size of the atom. Okay, so if we look at our subatomic particles, we're going to look at their what we used for their symbol, their charge, and their mass. So a proton is positive. So we give it a lowercase p with a superscript positive, and it has a mass of 1 AMU. An AMU is an atomic mass unit. We were measuring things in grams and things got kind of crazy and the numbers were so tiny that they stopped actually having meaning. So we came up with this atomic mass unit to measure atomic mass. The atomic mass unit is based on carbon-12. We are carbon-based life forms, and so we use carbon-12 as our basis or standard for a lot of things. So the mass of a proton is 1 AMU. A neutron also has that same mass of 1 AMU, but a neutron is neutral, so it does not have a charge. So its symbol would be a lowercase n with a little superscript 0. An electron is represented with a lowercase e. Electrons are our negative particles, circling that positive nucleus. And they have very, very little mass. So 0.0005 AMU. So they're really, really tiny compared to a proton or a neutron. So when we talk about the mass of an atom, we really only consider the two things that considerably change an atom's mass. And that would be the protons and the neutrons. Because even if you had 10 electrons, it would still not really significantly change your mass, hardly at all. Not like a proton or a neutron can. Okay. So the mass of an atom is its protons plus its neutrons. So that's going to be really, really important. We can find the number of protons that an atom has very, very easily by using the periodic table. And what tells us the number of protons is the atomic number. And I'll show you where that is on your periodic table here in just a second. It is different for every atom. And in fact, the number of protons determines what an atom is. So if an atom has 6 protons, it is carbon all day. If something happens and it has 7 protons, it's no longer carbon, it is nitrogen. So each element has a unique atomic number. So it's like nothing else on the periodic table. Okay, so if we were to look at a block on the periodic table, you're going to see something that looks like this, where you've got this element symbol. The atomic number is the number at the top. And that is your number of protons. And that's how you're going to identify it with a lot of these particular atoms. It also has the element symbol and the element's name on your periodic table. And then you have a number down here For carbon, it looks like this. That is going to be the average atomic mass. And we'll talk about that here in just a little bit. But it is an average mass of all the carbons that are out there. So if we're looking at a particular element, we can figure out how many protons, neutrons, and electrons there are by knowing what the element is and knowing its mass. So we also would be able to figure out the number of electrons if it were electrically neutral, because our protons equal our electrons. So our positive things equal our negative things, making a neutral atom. All right, so let's deal with neutral atoms here for a second. If I look at, let's say I have carbon, and I know that it has a mass of 14. I want to know how many protons, neutrons, and electrons there are. So the number of protons, I would get that looking at the periodic table. Find carbon on the periodic table, and its atomic number is the number of protons. So this, I have 6 protons. My neutrons, the way I'm going to get that is I know that my protons plus my neutrons give me my mass. The mass is 14. My protons are 6. And so if we're looking for our neutrons, we can just solve for this. If you are looking for your neutrons, it is going to be mass minus protons. So that is going to be 14 minus 6 in this case, and that's going to give me 8 neutrons. Now, the number of electrons, this is electrically neutral, so our negative things equal our positive things. I have 6 protons, so I'm going to have 6 electrons. And that's how you figure out the subatomic particles in a neutral atom. These atoms won't be neutral for very long because electrons, since they are on the outside of an atom, can be lost or gained during chemical reactions, and they become a little more interesting to us. But first, let's practice with neutral atoms. So I have some practice for you. And let me pull this up here. If you would, just give these a shot. You will not have to use the periodic table for this. The only thing that should be used to fill out for the periodic table is the symbol. And you can use the atomic number to look up the symbol. But all these other numbers you should be able to get from the numbers that are given. So take a moment, pause this video, and then fill out this chart. Then you can restart the video and I'll go over the answers. Okay, so let me go over the answers here of these guys. So our atomic, we were given here the number of protons. We know that the number of protons is its atomic number, so that's how we put our 8 in here. We also know in electrically neutral that protons equal electrons. So our positive things equal our negative things. We have a mass of 18. 18 minus my protons is going to give me my neutrons of 10. For potassium, it gave me the atomic number of 19. It gave me the atomic number 19, so I know that's how many protons. And because it is electrically neutral, protons equal electrons. So that's how I got a 19 over here. It told me I had 20 neutrons. So the two things that have mass are my protons and my neutrons. I add those together to get my mass number. And the symbols, oxygen's O and potassium is K, and we could look those up from the atomic number. Okay, so that is a neutral atom.